So we will be looking at 2016 and 2015. So we'll start by 2016 semester test 1. So as you know from last week, we are answering past papers. Hopefully this helps you to prepare for your semester test. Um, Sorry about that. So I was saying, hopefully you are mostly prepared by now since you're writing tomorrow. Uh, Hopefully you can grab one or two things from the tutorial. So question 1 says we have to draw a UML diagram for the specific scenario. So we have a UJ model which has a UJ mesh which defines the geometry of model, and a UJ image which defines its texture. An affine transformation defines a transform operation which modifies a UJ model. There are three kinds of transformation classes, namely rotation, translation, and scaling. So we are to draw this. So from the question, you notice the keyword has here. So we have a composition. So a UJ model is composed of UJ mesh, and the UJ image, defines its texture. An affine transformation defines transform operator. So let's switch to Lucy chart. So we have our class diagram. We'll name this. I think this is U. Usually, let me just check something. Okay. Usually this question is last, so I was just checking that it's the actual question. So it's only 5 marks, so we don't expect you to do much. You have UJ model. Defines a geometry. So let me just copy this. So we have UJ mesh. Then we have a UJ image. We also have affine transformation. So the affine transformation has an operation transform. So, and have a constructor here. And they say it has an operation transform, modifies a a UJ model. So transform. Make it void. So this is what you have so far under UJ image. So UJ model has both the UJ image and UJ mesh. So we're gonna have a composition here and here. So there are three kinds of transformations. So we have rotation, translation, spin. You can have kind of like a general association here. Uh, Something like this. Okay, I think this should be like delegation or something. Delegation. I think these are basically the main operations that we have. So if you do something like this, I think this should be enough because they don't expect you to do much for 5 marks. If you like, you can include some attributes like I don't know, name of the model, you know, things like that, ID, uh, the accessors and mutators. But in this case, I don't think it's necessary. So this is how UML diagram will basically look like. Oh, uh, mm, oh, since here we have a composition, so we're gonna have a private member here for uj image. So you can say something like image as uj image. You can also have something like mesh as uj mesh. Just to have the composition. Uh, that's basically it. You can also have accessors here for accessors and mutators for the image and the mesh. Image, return uj image. You can have get mesh, returns uj mesh. You can have set mesh mesh as uj mesh, and to void. And finally, you can have set image image as uj image void. Basically, you can have something like this. All right, let's move to the next question. So question 2, please write the most correct option in your answer book. A, we have which of the following, sorry, any questions so far? Let me see if, can anyone hear me? But I'm assuming you can hear me, so please write, let me see. Which of the following interclass relationship refer to as a relationship? So has a relationship is composition and delegation. So the answer here will be A, B. So let me just open that part. Question 2A, we have B as answer. B, what is missing from the following copy constructor? So we have a copy constructor here. So as we know, the copy constructor must have a reference to the original. So the missing item here is the ampersand. C, C++ has a dedicated syntax for message passing between objects. Message passing between objects. Mm, I don't think it has a dedicated syntax for that. I'm not really sure about this question. I don't don't know if they are referring to, when passing. Well, no, actually there's no dedicated syntax for that. The answer is false. Which can occur as a result of multiple inheritance. So when we have multiple inheritance, we usually encounter the problem of diamond. So the diamond problem, which is the scenario in which we have, like, for instance, you have a class A, B, and C, and both A, B, so C inherit from both A and B. So that is multiple inheritance. And now we have another class D, which is the base class of A and B. So if you have something like D, the children classes of D is A and B, and then we have C inheriting from A and B. That is, it forms like a diamond. So that causes a problem, because when calling the class or instantiating the C class, it's not gonna know which one to use as, which constructor to use. So the answer here is B. E. Which of the following is the most widely supported kind of inheritance across mainstream programming languages? Um, I think it's public inheritance, as you know. C. So from the portion of code here, you are given with a C star structure, a function pointer. So you want to identify A. As we know, you can see that there are variables declared in this structure. So this should be a structure, a data structure, and this should be the semicolon. So A is struct here. So question 3. B. B here we have, yeah, just like I was saying, we have another structure here, and then we have the missing semicolon here. So B semicolon. C is the implementation. So we have a function to string implementation here, which is implementation for, I think set pixel color. No, no, I think, yeah, I think it's set pixel color or something. Yeah, so string. Let me see. Yeah, I think it should be the implementation for setting the string. So as you can see here, we have a pointer to PO image, which is the structure here. So it's called self. So this refers to an instance of this particular variable. Now, to we want to assert, so validate the instance. So all we have to do is check that self is not null. So we're simply going to say if self is not equals to null. So self is not equals to null. You can use null or null pointer, something like this. Anyone works. So D, we have a for loop here. So as we can see here, we are looping through the number of rows gotten from the dimension. So we have a structure here which is called dimension, and it contains the rows and columns. So we can see that dimension is nested into the PO image. So that means the base class or something like, or the primary instance should be the instance of self. So if you say self dot PO image dot, yeah, we're gonna access those elements. So the answer should be self and then the arrow. So something like self arrow. The same here and here. So E, we have self and then the same thing. What are the members of PO image? You check here. We have pixel. Pixel has the corresponding variables for red, green, and blue. And as you can see here, we are trying to access red, green, and blue. So it should be pixels. So we're simply going to say E equals to pixel. Pixels. So the next one, we have F, converting string and returning. So F, we want to convert to string, and so we will simply take this what is this? This self, I mean the ppm, the converted ppm, and convert to string using the string operator. So the answer is going to be ss ppm at str. Then G, you have a destructor here. So this is kind of like the destructor in object-oriented format. Remember, when you have classes, the destructor is the tilde and the name of the class. And usually is the name of the two-dimensional array here. So, but since we have a way to refer to the current instance already in object orientation, C style doesn't know about it. So you need to infer the reference and the pointer to the reference of the PO image object. So this is going to be star and then ampersand. So is
Sorry to bother you, Mr. Futsing. You're very, very, very quiet. The students are asking on the Discord. I have to turn the volume all the way up to hear you. So just please note that you're not coming through very clearly.
oh Hi, can you hear me? you hear me now?
It's a little better, but it's still very, very soft. So I'm going to recommend that the students turn their volume up. But I think you're going to need to look into that. So do some tests where you record things and listen back and see if you can sort your audio things out. I don't think you'll be able to sort them out now. Um, but just for next week, please try and see if you can find out what the issue is. You can create some test sessions on Blackboard and record them and download and see if you can debug.
Okay, sir. Uh,
Okay, thanks. Good luck.
okay, so sorry about that. I had a problem with my mic. I don't know at which point, so apparently you wasn't getting anything. But okay, so far I don't think I can redo everything. So far I did question 2 and 3, and question 1 as well, the UML. So I was at H. Okay, H. So we have our destructor here, the destroy function, and basically here on H we are trying to deallocate the whole array. So usually we use the keyword delete to to deallocate the array. So H would be delete here. Yeah, I think we should delete. And I, okay, set point. So I is deallocate object instance. So I think it should be. Why is it like this? I know J should be. I'm not sure what this is. Deallocate object instance. I think I should be delete as well. Oh, I think H should be delete with the square brackets, and sorry about that because we are deleting. I guess it's a two-dimensional array. Let me see. Yeah, pixels is a two-dimensional array. So when we look through each of the each of the rows, we have to delete the corresponding columns for each of the rows. So this only deletes each of the columns in the pixel, and then the H, the what is this? The H will delete. I mean the I will delete the actual object instance of object image. So delete, and then J should be null, or you can use null pointer if you want C plus 11 features. So hopefully you can. Any questions so far? Can anyone hear me? Anyone can hear me? Okay. Mm. So the fourth question is composition and delegation. So we are given with a class, which is the UJ image class, UJ sharpener, and yeah, UJ image and UJ sharpener. So this UJ image is is manages the life cycle of UJ sharpener. So it kind of uses it to to sharpen, to delegate its tasks and perform its operations. So we are given A here, as we can see from the structure of the class. It's just public because I mean, what am I saying? Private. It's private. As we know, in a class we have a public section and we have a private section. So the private section usually contains members that are private to the class. So A should be private. We can see public here. We have the constructor. We have the main operation, which is compressed here. So A should be private. The B, UJ compressor, object compressor. So here we have, I think we have, okay, yeah. So this is where we create the composition. So this should be a pointer to UJ compressor. So B should be star. C, we have the pixel. So pixel, we are told that it's a two-dimensional array of color points, which means it should be star star. And D, we are given a function which compares two pixels or two colors, whether they are the same. So we are asked what should we return here. So from the function here, we can see if the green components, I mean the red components of both colors are equals or not equals, then we return false. If the green components are not equals, then false. Blue components not equals, false. So which leaves us with the only option if they are actually equal. So otherwise it should be true. So D should be true. E, we have a function add to string. So it takes in a string stream of ppm and a color with a run length. So E here we have red, green, and blue. So E should be the record color dot red dot green dot blue. So because we get the colors from the structure. So E is record color. F, so F is it's under the copy constructor. So to use the copy constructor, we call the init function. So let's check the init function. Well, init guess the function was perhaps omitted, but from the structure we can understand that init here will probably call a function and pass in the reference of the class to be able to use, to be able to instantiate the class. So init should be, I think it should be the this keyword, this.object original or something. I'm not very sure about this one. Can anyone hear me? So we have okay, we were on F here. So F should be object original. I think it should be object original here. Let me try find function. And then G should be object original dot pixels. Position RC. So H we have so this function is the destructor, so it calls a free pixel array function. So this should be the UJ image with the tilde at the front. So tilde. then I, we are given with the compress function here and the object compressor array. So this is where the delegation actually happens. So the missing component here should be, since you are trying to access the object, the the compress function from the object compressor. If you check in the object compressor here, the compressor has what? The compressor has a compress function which takes in an array of pixels. So this corresponds to what we want. So we're just gonna say compress, compressor, compress. So it's gonna be, let's see, dot compress. Here is gonna be, so after we compress, we return what? We return the array of pixels. So yeah, so it's gonna be, no, we return the compressed string. So it's gonna be str compress. For the last question, we have construct your own minimal example which demonstrate the following: inheritance, redefinition, constructor chaining, making data available to derived classes in a safe way. So, okay, basically you're asked to create your own example to demonstrate inheritance, redefinition, and constructor chaining. So you can have the example of um, what can I take? A student. So student, student as the base class, and then have comp sci students, informatics students, and we have math students. So we can have the example of students as the base class, computer science, informatics and math students as the subclasses. From this example, we can see that there is um, a relationship between students, and we have various kinds of students, which are computer science students, informatics students, and math students. So in this example, so this is the inheritance. The redefinition is maybe we have in this function in this class we'll have something like calculate mark function which will behave differently in each of the classes. So the calculate mark for informatics might be different from the calculating marks of computer science students, and also different from the way math students calculate their marks. So this way, this creates a redefinition of the calculate mark function. Now, inheritance constructor chaining. To chain the constructor, we can have we can have I don't know if you how can I do this? I don't know if this question should be answered in code, or let's see if there's any question. So constructor chaining. Remember, when we have inheritance, each of the constructors will inherit from the base class's constructor. So if you have something like if you have the constructor, so if you have the constructor student which takes in the name and student number, the child classes which are maybe the computer science student, they are going to inherit from this class. So when we define this class, we will have um, we'll just pass in the name. We'll have something like this, and then student, we pass in the name and student number, something like this. And this is done. This is done for each of the children classes. Finally, making data available to derived classes in a safe way. So to make data available to derived classes, we will use the we use what the protected visibility. So in each of the functions will be protected. So if we have like each of the private members, each of the data members in the computer science in this student class, which is the base class, will have a protected visibility. So if you have like name will be protected, student ID, student number, which is will be protected as well. So that is how we will demonstrate this. I hope there's no questions so far. I'll proceed to the next question. Okay, this is the end of this paper, so I'll move to the next paper. The next paper here, we are told that every staff member has a bank account, which is uniquely defined by a read-only account number. Money can be deposited into and withdrawn from such accounts. There are two different types of staff members, and namely part-time and full-time. All staff members have a unique staff number and are able to earn wages. The exact wage calculation differs between the types of staff member. So we have to model this using the class diagram. So if you go back to Lucid chart, add another page. So we are told that um, we are told that we have a bank account. Okay, staff member. So staff member. So we have staff members. We have a bank account, and there are two kinds of staff members, which is part-time and full-time. Full-time. So monies can be deposited into and withdrawn from such accounts. So the bank account has a unique identifier, so it's read-only account number. So read-only in this case tells us that there's only the accessor, so you cannot change the value of the bank account, the ID. So it's account number. You can make it an integer, and then we'll have an accessor for the bank account account number. Let's include the constructor first. So the staff has a bank account, so we create a relationship here. Uh, so there are two kinds of staff members, part-time and full-time. are the kinds of staff members, part-time and full-time. And we are told that money can be deposited into and withdrawn from such accounts. So we can deposit and withdraw money. So all staff have a unique identifier, so unique staff number, and also they are able to earn wages, and they earn wages differently. So we have a staff number. So it's an integer. Then we have also earn wages. So the earn wage function will be inherited by each of the subclasses. Earn wage, make it a void. So basically that is what we have. And I think that is all for our UML diagram. So let me just delete this. And yeah, that will be it for the UML. Any questions? Perhaps not. So question 2, we have which of the following which of the following indicates public visibility in UML? So as we know, public visibility is a plus sign. B, identify the following operation of reject class. Reject and then int parameter. So this should be a constructor because it's not a copy constructor because it doesn't have the object reference. It's not. I think it could be the default constructor, but it has an argument, so it's not default. No argument, so no argument is kind of like the default constructor in this case. It's not the destructor, it doesn't have the ticket. So answer here is B. C, we have the diamond problem is possible when using multiple inheritance. Yeah, true. Already explained the diamond problem. In which of the following language is object-oriented design possible? VB.NET, yes. C++, yes. JavaScript, yes. Python, yes. So the answer should be E, all of the above. So which of the following has a default private visibility? As we know, the class has a default private visibility. So it should be class. Enumeration, it has a public visibility. Structure, public visibility. I think even function pointers, they are public. We usually define them in the public section. So we have member variables. It could be public, it could be private, but by default, I think it's public. So I think it's the only thing here is a class. So A here, we are given a C style implementation. So we have a structure, POS, PO string. So Boolean here, the first thing you realize is this is a function pointer. So it should have a pointer here. So it should have a star. B, we have POS, PO string star, and then record POS. So this is kind of like the destructor. So we should include an ampersand for the reference. And C has a delete, so we're trying to delete the instance. So I think it's delete, yeah, delete array, so something like this. We have contents. So delete array, so delete like so. Then D, record position. So this sets to memory address 0. So this is simply setting to null. So this should be null. Then you have a mixed string function. Mixed string integer int length pos e rec return equals to f pos string. So pos string e here, e should be a star because we are trying to return this here. So this should be the same data type as the function. So you have to have a pointer there. So E is star. F, so F, we are trying to do it. I think we are trying to instantiate. So create an instance of POS string. So you have to use the keyword new. You have to use the keyword new g. So here we are assigning the characters to null, to empty character. So this dot equals to okay, let's see. We create a new instance of characters here. Then we pass in the null character here. Then we say equals. So let me check the equals function. I'm not sure about the answer for this. Return. I'm not sure about the answer for this. Compare strings. So we have these two strings. So the function should return, as you can see, we have a boolean true and false here, so it should be a boolean. So POS RBC record ABC is equals to so I think this should be new PO string. I'm not really sure about this. Let me check quickly maybe. Oh, I think I got it. So I have to call the function make string and pass in the length. So yeah, make string. So I have to call in the function make string digits. Make string and pass in the length. From there we can see that we have three things in the content. So the length should be 3. Then we have j, okay, j. So j, we are trying to call something here. I think is a free memory. So once we finish instantiating this, we have to free the memory. So J should be free memory. What is it called? A free string. Then we, oh, yeah, basically free string. That's all we have here. Yeah, so that's basically it. Question 4. What do we have in question 4? The following shows a subset of code which deals with a data set which has an analyzer. Calculations of averages are instead handled by the analyzer. The data set manages the life cycle of the analyzer class. So A here we can see clearly it's an enumerator. So because we have error codes and statuses, and we can see the comma here, it's not semicolon, so and there's no data type, you know, unlike a structure where we have actual data type. So this is enum. B we have, you can see here there's only one function, so it should be public. Then we have C. C, this line should be the copy constructor. So C should be a constant. The copy constructor has to have a constant reference here. Then D, we have private members here. So D should be private. E, analyzer. So composition, as we know, we need to put in the star in the analyzer. We have an instance of analyzer, so it needs to be a pointer to analyzer. So star. Destructor, here we have delete f. So what are we trying to delete? We want to delete the, as you can see there's an array here, so we have to delete the data. So this is actually the data. You can see there's an array of data here, so that is what we are trying to delete with the square bracket here. Then the second one is the instance of the analyzer that we created, so we'll delete analyzer. Then H, we have a function setup. It takes in the length, so we are trying to set the length here. So the length is a private member of what? Of the data set. So we have to say this that length equals to length to refer to the current instance. So H should be this. Um, analyzer equals to new analyzer. So because we are creating a new analyzer here, so I should be analyzer. Now J, we have a function calculate average. These are just accessors and mutators here. So we have a function calculate average. It should return what it should. This is where the delegation takes place. So it should return the thing that is, it should call the function in the analyzer. Let me check the function. The function is calculate average, and we can see it takes data and length. So this matches up with what we have here. So calculate average. So we'll simply say calc average and pass in what did we have again? We have the data and the length, so we can just pass in data and length. Since we are in the class, we can use the private members. Data. Last question. Last question. What do we do when the logical properties and implementation details of a programmer defined data type are kept separate? Okay, when we want to keep the logical properties and implementation, we use um, what is this? We use object orientation. Oh, this is actually how do you call it? Encapsulation or separation of concern rather. So we are trying to separate logical properties from implementation details from the programmer. So this should be separation of concern. B, which visibility level sits in between public and private? We have the protected visibility. C, which object-oriented programming technique is used to define an easy relationship? As we know, it's inheritance. D, define the term encapsulation. Encapsulation is so encapsulation is the process encapsulation is the process of grouping data and behavior in a single unit. So E, we have delegation is one possible object-oriented code reuse technique. With which kind of object relationship would it be used? It's usually used with the has-a relationship. Has-a. When we have a composition, that's when we can delegate tasks. So isn't the code convention established in class, which source code file would be needed to define and implement a class called shape? Oh, here we're referring to different classes we use, the different files. So we usually have a header file, and, header file which is the .h, and we have an implementation. Uh, which is the .cpp. Okay, G, say complete the following. So AN is an in-memory instantiation of AN. This. Uh, Let me see. I'm not sure about it. Let me move to the next. Is the method used in question 3 ideal? Question 3. mm, Oh, question 3, they're referring to the C-style implementation. So they're asking if the method used to define things using the C-style implementation ideal. It is not ideal because I think it's because it is not object oriented. So it's not object oriented. So we cannot easily, we don't encapsulate data. We don't, it's not following the principles of object orientation. The last question, I, what effect does the static keyword have on a data member or function? So the static keyword gives a unique address in memory, I believe. So when creating constant, so that you cannot change the actual reference in the memory, so gives unique address in memory. I think the const keyword makes the variable not changeable, but this one gives a unique address in memory, so something like that. All right, so I think this is it. Let me check in memory. I wanted to query about this question, in memory instantiation. Mm, I think so. I think this should be something like new a. I'm not sure. I'm not sure about this. So I guess this is it for the tutorial, and hopefully you got something, and we'll call it a day. Thank you so much.